Hello and welcome to earthquake tip number 11. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially architects and engineers. Before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. The earthquake tip number 11 will give you details of all available Indian seismic codes that can be used for earthquake resistant design. Before I introduce various seismic codes of the country, let me tell you why do we require these seismic codes and follow them religiously. You know by going through previous tips that structures need to be designed to withstand forces and deformations caused by ground vibrations during earthquakes. Seismic codes help to improve the behavior of structures so that they can withstand the earthquake effects without loss of life and property. Around the globe, countries have procedures outlined in seismic codes to help architects and design engineers in the planning, designing, detailing, and constructing of structure. If I have to tell you the importance of earthquake codes, let me first tell you that an earthquake resistant building should have four virtues as shown here. Good structural configuration means size and shape of building and its structural system carrying load are such that they ensure a direct and smooth transfer of inertia force through the building to the ground. Lateral strength is the maximum lateral means horizontal force that building can resist so that the damage induced in the building does not result in life-threatening collapse. Adequate stiffness is the stiffness the structure should have lateral load resisting system such that the earthquake induced deformations in the building do not damage its contents, that is, non-structural components under low to moderate shaking. Good ductility, the structure capacity to undergo large deformation under severe earthquake shaking, even after building is improved by incorporating design and detailing strategies. All these aspects are covered in detail in seismic codes. Now let's look at the Indian seismic codes. First of all, seismic codes are unique to a particular region or country. These codes take into account the local seismology, accepted level of seismic risk, building typologies, and materials and methods used in construction. Also, they are indicative to the level of progress our country has made in the field of earthquake engineering. The first and foremost seismic code in India was namely 1893, which was published in 1962. And today, Bureau of Indian Standard has the following codes as shown in this figure. Let me also tell you here that these codes, which I will be explaining you in detail, uh, the stipulations given in these codes or standards do not ensure that structures suffer no damage during earthquakes of all magnitude. Remember, the tip on earthquake design philosophies, to the extent possible, codes ensure that the structures are able to respond to earthquake shaking of moderate intensity without structural damage and of heavy intensity without total collapse. Now let me explain you all these codes one by one. IS 1893 is the main code that provides the seismic zoning map of India, which is shown in this figure here. This code specifies seismic design force. The seismic design force depend on the mass and seismic coefficient of the structure. This seismic coefficient depends on properties like seismic zones, which are shown in this graph, importance of the structure, its stiffness, and the soil on which it rests and its ductility. For example, a building in Bhuj, which falls in seismic zone 5, will have 2.25 times the seismic design force of an identical building in Mumbai, which falls in zone 3. Similarly, seismic coefficient for a single story building may have 2.5 times than that of 15-story building. As you can see in this figure, India is divided into 4 zones, zone 2 to zone 5. Zone 2 is the low damage risk zone, whereas zone 5 is the highest damage risk zone. More than 50% of India's land area fall under seismic zone 3 to 5, means moderate to high damage intensity. IS 1893 Part 1 was revised in 2002 after Bhuj earthquake and contains provisions that are general in nature and those applicable for buildings. It has 5 other parts. Part 2 covering liquid retaining structures, both elevated and ground supported. Part 3 bridge and retaining walls. Part 4 industrial structures including stack-like structures. Part 5 dam and embankments, and part 6 is the recent addition, which is on base isolated buildings. Let's move to the next code, which is IS 4326. This code covers general principles for earthquake resistant buildings, selection of materials and special features for design and construction for various types of buildings, namely timber construction, masonry construction using rectangular masonry units, and buildings with prefabricated reinforced concrete roofing and flooring elements. Guidelines in IS 13827 deals with empirical design and construction aspects for improving earthquake resistance of earthen houses, and those in 13828 with general principles of design and special consideration features for improving earthquake resistance of buildings of low strength masonry. This masonry includes burnt clay brick or stone masonry in weak mortars like clay mud. These standards are applicable in seismic zones 3, 4, and 5. Constructions based on them are termed as non-engineered construction and are not totally free from collapse under seismic intensities 8 and higher, that is seismic zone 4 or higher. Inclusion of features mentioned in these guidelines may only enhance the seismic resistance and reduce chances of collapse. IS 13920 in India, reinforced concrete structures are normally designed and detailed as per IS 456-2002. However, structures located in high seismic regions require ductile design and detailing. Provisions of ductile detailing of monolithic reinforced concrete frames and shear wall structures are specified in this IS 13920. After the 2001 Bhuj earthquake, this code has been made mandatory for all the structures in zone 3, 4, and 5. Similar provisions for seismic design and detailing of steel structures which are not earlier available are now being published through Indian standards. IS 13935 and IS 15988. These guidelines cover general principles of seismic strengthening, selection of materials, and techniques for repair, seismic strengthening of masonry, and reinforced concrete buildings. Some guidelines are also laid down for non-structural and architectural components of buildings. Earlier, there was only one code, that is IS 13935, covering both types of buildings, but now this code is split into two, that is 13935 and 15988, covering masonry and reinforced concrete buildings separately. Before I end this tip, let me tell you that countries with a history of earthquakes have well-developed earthquake codes. Thus, countries like Japan, New Zealand, and United States of America have detailed seismic code provisions. Development of building codes in India started rather early. Today in India, we can also boast to have fairly good range of seismic codes covering a variety of structures, ranging from mud or low strength masonry houses to modern buildings. However, the key to ensure earthquake safety lies in having a robust mechanism that enforces and implements these design code provisions in actual construction. That's all about this earthquake tip number 11. You can download this tip from www.bmtpc.org. The next earthquake tip number 12 will be on how do masonry buildings behave during earthquakes. Thank you very much.